टीम पर बना रहा है इस चेयर में बैठ नहीं आया तो
I think all of the participants are added. So we can start.
Yes, yes.
Yeah, okay. Hello and good evening to all of you. I am Asim Rastogi, a co-chair of Future Leader Forum. And on behalf of CAI, I welcome you all for today's webinar on transport planning, road safety, and traffic engineering by our eminent speaker, Mr. Shivendu Seth. Future Leader Forum basically is in with CAI and was formed in 2012 with the intention to provide young professionals with an opportunity to participate in CAI, FATIC, and other Asia Pacific programs and interact with their peers and help them to develop as the next generation leaders. Future Leader Forum here is interested to deliver webinars on various topics covering all fields of engineering, and by this we will give an opportunity to learn from each other and provide better field understanding to the upcoming and practicing engineers. So after this, I'd like to introduce our CAI Vice President, Mr. JBL Naranasam, who will be giving opening remarks for this webinar and a brief about CAI. Mr. JBL Naranasam is a civil engineer and transport planner by education and has about 30 years of professional engineering experience in consulting engineering business in the area of transportation, water building, environment, and urban planning. He has held senior level management positions, including Managing Director, Resident Director, President, Senior Vice President, Head of Operations, Technical Director in leading international consultancy engineering firms like Royal Housing, DHV, Netherlands, WSP, Elcro, etc. Prior to his current employment. Currently, he is working as Regional Director North with RV Associates. He has extensive experience in working on planning, feasibility, design, and construction supervision of various transportation, water, buildings, and environmental projects. He is expert not in only India, but also in abroad, like in US, Sri Lanka, Netherlands, South Africa, and Vietnam. So now I like Mr. Naranasam to give his...
Thank you, Mayor. Thanks for that introduction. Good afternoon, everyone. I hope I'm audible.
Yeah, sir, you are audible here.
Yeah, okay. Good afternoon. Very warm welcome to all the participants on this very interesting subject. I'm extremely happy to be part of this webinar organized by CEI Future Leadership Forum. You all may be aware that CEI is an apex body of consulting engineers in India, having memberships of organizations as well as individuals. Now, it was incorporated in 1996 with the merger of two leading national associations, Association of Consulting Engineers India, which was established in 1960, and National Association of Consulting Engineers, NACE, which was incorporated in 1976. Thus, you could see that we bring in about 6 decades of accumulated experience as CEI, and we have about 500 plus members today, representing large, medium, small consultancy companies and organizations, both from public and private sector, and eminent individual consultants. CEI is also a member association of the International Federation of Consulting Engineers, commonly known as FEDIC, representing the consulting engineering fraternity in India. Now, the objectives are quite clear, and it is advocating global networking cooperation amongst the consulting engineers. Quality development is a key thrust, along with production and enhancement of consultants' expertise. Promotion of ethical practices of consultants is very key and pivotal for us. And then facilitation and interaction with government and other authorities to streamline and improve the system of working and constraints that the consultants face from time to time are some of the key objectives of CEI. Looking at the Future Leadership Forum as an excellent team of young, dynamic, talented professionals with very high ambition and goals to learn and grow. Now, we at CEI are proud of our Future Leadership Forum. The CEI encourages Future Leadership Forum to conduct, participate, learn, and grow in their respective areas, including training, professional management organized by the FIDIC. The Future Leadership Forum organizes meetings, as we have said a while back, webinars, workshops at regular intervals to learn on various technical, financial, contractual, management, and all the aspects that covers the consulting engineering business. In the last few months, we have already delivered some of those webinars, including a modern trend in design and construction of extra dose bridges in April, design and construction of NATM scissors crossovers in May, legal and general aspects of contract process and contract administration in June, and flow transition design in hydraulic structures in July. And then the enthusiasm shown by our Future Leadership Forum in organizing these seminars is highly appreciated. I'm also excited to see a large number of participants today, and I'm confident that the webinar on transport planning, which is close to my heart, my education, my practice, and road safety, traffic engineering, will not only provide insights to the state of art of working, but also bring you the best practices. My best wishes to one and all, and I hope we will go have a fantastic learning program. Thank you.
Thank you, sir, for your kind words. And now moving forward, for today's webinar, our moderator will be Ms. Sanjita Nayak. She has impressive academic record of having a master's in international construction, practice and law from prestigious University of Stuttgart, Germany. He is a member, also secured mixed member of Royal Institute of Chartered Surveyor UK, and she is recognized as a qualified APC assessor, primary reviewer, and the consular by RICS UK. She is a contract management professional specialized in claims, variations, delay analysis, and quantum analysis of construction contract. She is also member of Association of Project Management UK, graduate member of Institution of Civil Engineers UK and a member of Institution of India. After completing his assignment as a contract engineer for SMCC ITD Japan in their metro rail project, she is currently working as an assistant general manager with Tata Projects Limited. So now I like Ranjita to introduce our Suvendu sir and way forward this webinar.
Thank you, Asim. Good afternoon, fellow engineers and renowned professionals present here today. Today, we are so fortunate to have Mr. Suvendu Seth here as our speaker, who will be giving us an overview his 30 years of rich experience confined into the subject transportation planning, road safety, and traffic engineering. So as we can see from his profile, the acquired qualifications, certifications, and the professional journey is spread across the nations, in fact, continents. So he had been serving very major key roles in various MNCs, and he had been a part of various projects funded by multilateral development banks. And now he is presenting himself as a independent consultant specializing in the transportation planning field. So having said this, I would like to welcome Mr. Suvendu Seth on behalf of Future Leader Forum of CEI for the session. And we are all ears. Over to Mr. Suvendu Seth. Sir, the platform is yours.
Thank you. Thank you for the introduction. And good afternoon, everybody, all the fellow engineers. I will try and share my, let me see, share the screen. Is it visible?
Not yet. Not yet.
No, sir.
Let me see why I'm having difficulty.
If you want, I can share the screen.
I think it will be better. I'm having some difficulty in sharing this. Some issues with security. Yeah, that will be nice. Yeah, let us go to the first one, please. I'll just say next, and so that, yeah, you can put the full view of that. Thank you. Yes, good afternoon, everybody. Good afternoon again. My presentation today is on transport planning, road safety, and traffic engineering. As you can understand, transport planning, road safety, and traffic engineering are all three huge subjects. And I'm just going to give an overview because in the limited time, I cannot go in details, just an overview. I'll start with transport planning. Next, please. Yeah, we all have a basic idea of what transport planning is. What it does is it's a process of looking at the current state of transport in the region, then developing and designing for future transport needs, combining it with the budgets, goals, policies. It helps cities and communities to grow. And it not only looks at one particular mode of transport, but various modes of transport, like highways, roads, public transport, also non-motorized transport like bicycles, pedestrians, and not only passengers, but goods vehicles also. It influences business, recreation, social integration, and the quality of life. Next, please. The purpose of transportation planning is to provide safer, smarter, faster, and more convenient modes of transport. We can look at two aspects, the planning aspect and the programming aspect. Plan is more of a long-term view of the transportation strategies, like it develops visions, goals, objectives, and then the strategies to support the vision, and then establishes a long-term approach to implement those plans. Programming is much more of to do with prioritizing the projects, matching the projects with the available funds, and establishing a tangible expenditure in terms of so as to implement the project and achieve success in it. Next, please. The process of transportation planning, we normally refer to it as a 3C process: comprehensive, cooperative, and continuous. Comprehensive because it covers the entire area of planning area and also various jurisdictions and various modes of transport. Cooperative because each jurisdiction needs to interact with each other in cooperative manner so that transport planning for the entire area can be possible. Continuous because we cannot just make a plan and keep it. It changes with time, over time. It involves land use, air quality, water quality, environmental policies, social equity, and there are a lot of stakeholders. First and the foremost are the citizens. The plans are made for the citizens. Then the businesses, governments at 3 levels: local, state, national level. There are various specific interest groups which are involved in transportation planning, starting with maybe public transport, pedestrians, and various other interest groups. And it works all works within a legal system. Next, please. To look at it in overall way, first, in a process of transport planning, we set up visions and goals and objectives. Then we study the existing and the future conditions. Needs are assessed, strategies are developed, then projects are selected and prioritized so that they can be executed one by one and then implemented properly with funds. And the most important thing is, after they have been implemented, they need to be monitored so that actions can be taken to change something if required. Next, please. The goals for transport planning are, first of all, access to employment, which is connecting the employment areas with the residential areas so that people can have their employment. Then freight mobility, safety, security, congestion mitigation, multimodal connectivity, and maintenance. These are all the goals that transport planners try to achieve through the transport plans. Next, please. There are often 3 terms which are used: mobility, accessibility, and connectivity. I'll just spend 1 minute going over the terms. Mobility refers to the ability to move between different areas. Now, if there is a system which gives a very high degree of movement, that is very fast movement, that we call it highly mobile. Accessibility refers to the number of activity sites that can be connected. So activity and mobility are inversely related. If a system has very high accessibility, it will have less mobility. And connectivity is a relationship of the locational area with respect to destination. So we can say that this particular area is well connected to A, B, and C. So these are overall ideas of mobility, accessibility, and connectivity. Next, please. First, I'll talk about the present scenario of transportation, which we are all aware of. All categories of road users face problems in commuting, everyday commuting. Then we know that pedestrians do not get a safe place to walk. Often they have to have obstructions in the pathways. Cyclists find it very difficult jostling between fast-moving vehicles. They do not have dedicated ways in most of the cities. Users of public transport face long and waiting periods. Service is often not good. Travel time takes a long time to travel. Road users get restless, resulting in road rage, rash driving, and road crash, which is not at all good. Next one, please. And there is deficiency in transport infrastructure in terms of quality of transport and also in quantity of transport. More modes like walking, cycling, and public transport are often neglected, and the uses are also decreasing. There's a preference for people to get first two-wheelers, and then they can afford to go to cars. And this, in their way, gives rise to more congestion, reduction in road safety and mobility, and increasing in the use of fossil fuels and road crashes. Next one, please. There are some photos to share with you. This could be from any city in India. Crowded buses, crowded trains, roads congested, trucks waiting, people on the road, walking everywhere. This is from various cities, but it could be in any cities. And I'm looking at mostly urban transport. Similar situations can happen in rural areas also in a different way slightly. Now, to address these issues, our National Urban Transport Policy was developed in 2006 and again revised in 2014. It had a vision. The first vision was to recognize that people are at the center stage of all the plans, and it should be for them, for their benefits, and to make cities livable and if the cities are livable and people can do their work properly, then it can turn into engines of growth. To allow cities to evolve in urban form that best suits the geography and supports the socioeconomic activities in the city. Because one model may not fit into another city because their geographies are different, socioeconomic characters are different. To encourage growth along low carbon path. Next, please. The objectives for the the new policy is to plan for movement of people, not for the vehicles. As he said, the first goal is the people. Sustainable mobility for all citizens, not only for a few people. An equitable allocation of road space for all modes. Normally, we tend to think of the cars and the vehicles first and then think of the other modes. But this policy talks about equitable allocation of space for all modes. Encouraging walking, cycling, use of public transport. These are the sustainable modes of transport. Improve road safety. Financing through innovative mechanisms. And introduction of intelligent transportation system, ITS. Next, please. The approach is avoid, shift, and improve. Avoid the demand of travel so that less number of trips are then made, less lengthy trips are made. Shift from personal modes to more public modes and non-motorized modes, and improve strategies for use of cleaner fuels, cleaner vehicle technology for sustainable transport. Next one, please. One important thing in transport planning. Sorry. Okay, I'm continuing. One important thing in transport planning is multimodal integration. This is integration of various modes of transport. That is, you can have the metros, BRTs, LRTs, local trains, buses, trams, water transport. Integration is very important, and it improves access and coverage, and avoids duplication of services in the same areas. The idea is to make trips short in time and in distance. Minimize the number of transport points to make it easy for people to transfer from one mode to another. The various aspects of multimodal integration are the physical integration, information integration, and fare integration. I'll go over it in short. Next, please. The first one is physical integration. This means co-locating various modes of transport. For example, a taxi stand or a bus terminal right outside a railway station, or walkways to connect buildings. These help people to move from one mode to another mode. And connecting network of at the airport, the connections with the LRTs or trams or metros, or by ferries, walkways, so that it's easy for people to use one mode and go into another mode. Terminals and station facilities are very important for transfer, and facilities like storage of cycles or walkways help people to access the terminals in a better way. Next, please. Here I've shown some pictures. The left one is from Hong Kong, which shows ferry connections from various parts of the city to the airport for easy access to the airport. But then another one is from Bangkok, where the connection is given a walkway directly from the metro station to the mall so that people can directly come by trains. The next one is from China, in Guangzhou, where cycleways and cycle sharing facilities are right next to the BRT station. So one can use the cycles from home, come to the station, take the BRT and go to the work. And the other way, they can come back and maybe rent a cycle and go home. So these are integrated facilities. Next one, please. Then coming to integration of information. This is linking operational characteristics from one mode to another so that passengers can transfer very easily. They have the information to see where is the next stop, what kind of facility is available, and so on. And this information communication can be either by static mode or by dynamic mode. The old way was by static mode, which was by timetables, maps. And nowadays we can have a dynamic real-time information on your web application where you can see that where is the next station, when is the next train, when is the next bus, and so on. And use of same ticket is also very useful so that one does not have to go and buy tickets for every system. One ticket covers all. Next, please. The next is wayfinding. Wayfinding means by means of signages, marking, so that it is easy for people to move from one system to another. This should be easy and intuitive. Information can be easily seen and understood. Considers clear and legible signs and markings. Entry exit should be clearly shown. Information should be all around the station so that even if one misses one, they can see the next one. And it should be in standardized forms, layouts and signs so that one can recognize the signs and look for it in the next place. Next, please. Here's an example. This is from Rio de Janeiro, where maps are shown to indicate stations where the locations are on the map. And on the right side, the wayfinding map from Vancouver, which shows the ferries, the bus and train station, and also the walking time from one to the other, so that one can estimate and go accordingly. Next one, please. Then comes the integration of fares. If the fares are integrated, it will be easy for passengers to transfer between modes. They do not have to pay every time. Common card is one example, Oyster card in London, which can be used for buses, for underground. And then common transfer, free transfers between train and bus. If you have a train ticket, you can get a ride in the bus or the other way around. And integrated ticketing, like if you ever go into the airport, you can get a free shuttle or use of shuttle with paid parking. These facilities can encourage people to use multimodal transport. Next, please. I'll come to another topic, which is transit-oriented development. This has become quite common now in several parts of the world. It is a development around a major transit station. This transit station could be a railway station or a BRT station where mass transit can occur. It reduces the dependence on a car, allows residents to live and walk and play in the same area so that distances are reduced, provides access to better quality of life, and stimulates local economy, revitalizes the urban areas. Next one, please. The components of a TOD are walkable design with pedestrians at the highest priority. It's designed around pedestrians first. And train stations are the prominent features. Mixed land use is encouraged. Offices, residential and commercial buildings so that people can do their work easily. After walking, it's bicycle facilities, rental and parking facilities. Reduce, manage car parking, and car parking can be put in the peripheries because emphasis on car usage is less. Specialized retail can be put up in the station areas so that people can do their groceries, can go to the cafe or restaurants. And density and high density residential commercial building is encouraged. Next one, please. Here, a couple of examples from of TOD. This is from, left one is from Lake Merritt TOD in Northern California. And the right one is from Sydney. It shows the train station is right integrated with the buildings so that from building people can get down and take the trains. So it's very easy for them to use. Next, please. This is an example from India where a TOD is being planned in East Delhi, in Anand Vihar and Kakaduma metro station around that area by NCRTC. It's in the planning stage. Next, please. The next topic is on inland waterways. In India, we have always had waterways, but somehow it wasn't very encouraged for quite some time. In the last 10 to 15 years, it has picked up again. The major waterways are the NW 1, 2, 3, 4 on River Ganga, Brahmaputra, in Kerala in the west coast, and on the Krishna rivers. Jal Vikas project was taken up to connect between Varanasi and Haldia, so have a fairway. And this project is still underway. And apart from these are the overall country level, but in the urban areas, water ferries are also getting improved. We already have water ferries in Kolkata, Guwahati, Kochi, and Mumbai. Next one, please. This is a figure showing the waterways in eastern India. Ganga, Brahmaputra in Assam and in the states of West Bengal, Bihar, Jharkhand, Uttar Pradesh. And we also have a protocol route, India going through Bangladesh. And this is used for sending goods, ships through Bangladesh to Assam from Haldia. And this has been going on for some time. And this has encouraged water transport. Next one, please. For urban ferry services, the important thing is to look at routes and service types. Traditionally, the service type has been cross-river, from one bank to the other bank. Generally, there are three types of services. Either it's a linear system, where the various points along the river are connected, or it can be a simple river crossing or a 3 points, 2 points on one side and 1 point on the other side. And it could be also linking suburbs with the inner city. I'll give some examples next. Next one, please. Here, in the left one is in Brisbane, where we have a long distance service from inner areas to the main city. And again, an express service inside in Brisbane to connect to various points along the river. Amsterdam, the example is here from to connect point to point across the river. And there are many ferry services across the river for people to use. Next, please. This is from Stockholm, where all the 3 types are present. We have the A type, which is in blue, connecting various points. B type, which is in red, which is 3-point connection in the city, and the yellow one, which is connecting the inner areas to the city. All the 3 types are present there. Next one, please. Sydney Ferry Service. Sydney has a very extensive ferry services. Ferry services where Circular Quay is a main point, which is well connected by ferries to various points, and people use it every day. And Circular Quay is well connected with the bus system, pedestrian ways, and cycleways. Next, please. The major issues in water transport, in urban water transport, are integration with transit network. It has to be well integrated with other networks so that people can use it very well. Terminal design is important. Sitting areas are needed, shelter, ticketing, information, and connection to other modes. Accessibility, comfort, and public perception. Public perception is important because if public has a perception that ferry doesn't go on time, it's not reliable, then people will not use it. Another important point from the aspect of vehicle design, all kinds of vehicles, vessel cannot be used in the ferries. There are specific types of vessels to be used. This is a major aspect of water transport. Next one, please. Here's another picture from London, the map for London Underground, which shows the connectivity to the various river stations, so that people can get down from the underground and go to and use the ferry. Next. Some pictures from India. Kolkata Ferry Service, which has been there for a long time. Guwahati Ferry Service, which has also been there for quite some time and is now being modernized. Kochi is a new water metro system, and it connects the various inner areas to the newly created metro through this water metro. Next one, please. Now I'll go to the next topic, which is road safety. This is a very important topic. I'll just touch on a few points in road safety. Next one, please. First, I'll give a few statistics, which are not very nice. Nearly about 1.2 million to 5 million people die on the roads from road crashes. And 3,287 people die every day. This is just the number of fatalities. Then on top of it, there are people who get injured or disabled. That's a huge number, 20 to 15 million people. I won't go over all the statistics, but just to say that most people affected are young people between the age of 15 and 44. And there's one sad fact is over 90% of all the road fatalities occur in low and middle income countries, where these low and middle income countries have less than half of world's vehicles, but contribute to more than 90% of the fatalities. Next one, please. The situation in India is also not very nice. We have more than 4.5 lakh crashes occurring every year, and this is a few years old, so it may be even more now. And the fatalities are more than 1.5 lakhs. And again, here also in India, young people who get hit, injured, killed. And the national highways comprise around 2% of the road network, but contributes to 30% of crashes and 35% of fatalities. State highways comprise of 3% of road network, but contributes to 25% of crashes and 27% of fatalities. And the pedestrians, cyclists, and two-wheelers together contribute to more than 54% of the fatalities. So these are the vulnerable road users. Next one, please. A global plan for road action for road on safety was developed. It's from 2011 to 2020, but it has now been extended to 2030 to address this issue of road safety globally. 5 road pillars were made, which could be addressed to address the road safety issues. These were road safety management, safer roads and mobility, safer vehicles, safer road users, and post-crash response. Next, please. There are various approaches to address road safety. When I'm talking of the engineering parts only, there are various other non-engineering aspects also, which I'm not touching today. The 3 main approaches here are the crash analysis, the mitigation measures, road safety audit, and international road assessment program. I'll just go over briefly over 3 topics. Next, please. Crash analysis is the first one. Next, please. Crash analysis, what it does is identifies the location where most crashes occur, then quantifies what kind of crashes occur, what are the problems, why it occurred, and then tries to find out improvements, what can be done to improve the situation so that these crashes can be avoided, and then implement those actions so that the situation can be improved. In short, that is what is done in crash analysis. Next, please. One important analysis tool in crash analysis is a collision and condition diagram. Here, a graphical representation of what exactly happens, why the crash happened, and there are various legends like rear end crash or it's a left turn crash, as various symbols are used, and they're put in the figures so that one can understand just by taking a look at it what kind of crashes happened, how many crashes happened, and was it injury only, or was it with severe injuries or fatalities. So it can be understood from this, and also the day, time, and the weather conditions are put in this map. Next one, please. The various causes of road crashes, the road users, and other causes also. The typical road user causes are excessive speeding, and the not obeying traffic rules or failure to perceive the traffic situation ahead. Probably the signs or signals could not be read. Carelessness, fatigue, drinking and driving, and sleep. These are the major causes of road crashes by the road users. Next one, please. Then there are reasons for vehicles, which vehicles were probably not functioning properly. Road conditions, it was either foggy or it was either skidding or road surface was not good. There were potholes, ruts. Road design could be flaws in the geometric design. Side distance available was probably not proper. Shoulder widths were not present. The curves were too sharp. Traffic control devices were probably not right. Next one, please. And there are environmental factors like snow, mist, fog, which one could not see the road properly. And apart from that, there could be other causes also. Like, for example, there could have been a big advertisement board which blocked the vision, or a level crossing gate did not close properly. This could be reasons also, but most important are the users' causes. Next one, please. If you look at the crash factors, human factors contribute the maximum to the crashes, followed by environmental and vehicle factors. And when they overlap, it becomes even more risky. Next one, please. Crash data collection is the first step to crash analysis. Police has the responsibility of keeping the records for crashes. The engineer has to gather the record, analyze at what spots those crashes occurred, and then analyze why it happened and what actions to be taken. Next, please. The crash data that is collected are normally they are the date, time, where it occurred, the location, what type of vehicles were involved in the crash, the nature of the crash, and draw collision diagrams from it, and find out the number if it was injury only or property damage only or fatalities. These things are all analyzed. Next, please. Now, the next question is about the black spot. Black spot we hear a lot these days. Black spot are basically where number of crashes occur. So it's called black spot. According to the MORTH protocol, any location where totally more than 5 accidents have occurred in the last 5 years, or any location where more than 10 fatalities have taken place in the last 3 years, that is called a black spot. And by spot, we don't mean just one location. It's about 500 meters length. In that length, if these things have happened, then it's defined as a black spot and action needs to be taken. Next, please. Coming to the next part of road safety, which is road safety audit. A road safety audit is a formal process. It assesses the potential for crashes to occur. It does not do crash analysis. It sees where crashes can occur. And it can be for existing road or a future road. We can study the plans. It can be traffic related projects, a project which interacts with other road users. And this is separate from actual design because it looks at the possibilities or the risks where crashes can happen and focuses on the physical elements of the road. Next, please. The aims of road safety audit are to minimize the risk and severity of accidents, to minimize or avoid accidents on the network, and meet the needs of safe usage by all kinds of users, not only on specific type of users. Reduces the long-term cost of schemes, because if we can take actions early on in the project, costs can be saved later on. Improves the awareness of safe design practices. And nowadays we use safe system approach to find out the mitigation measures. Next one, please. The principle is prevention is better than cure. The difference with crash investigation is crash investigations looks at the existing road and existing type and accidents that have occurred and suggests how to treat it, then monitors and evaluates it. But road safety audit attempts to predict accidents and then take action before it occurs. Next one, please. Now, who should be carrying out the road safety audit? Road safety audits should be carried out by an independent team. The independence from the design team is very important, because if the designers do the road safety audit themselves, they will be very partial towards their design. So it's always advised to have an independent team. The team should be having at least 2 people, maybe 3. They should be experts. I mean, they should have knowledge and experience in conducting road safety audit. They can be traffic or highway engineers, road safety educators. They can be traffic police people also, could be maintenance specialists also. But important part is they should have experience and they should have the qualifications. Next one, please. There's some photographs to show the road safety situations and the flaws. This is the first one. In the top left, there's a accident, inadequate protection made by stones. This we find normally on the road, which is itself a hazard. The stones can cause a hazard. And on the right side, there's a median and the median drain. This is an accident waiting to happen. A vehicle can just swerve off and fall down there. And in the bottom one, trees have been cut and placed right on the shoulder. This is also an accident waiting to happen. The right side bottom, we have a photograph of a road meeting a highway. And now there is no control on this. Slow-moving vehicles can come in and enter the highway, and then high-speed vehicles can come and hit it. Next one, please. There are road safety problems here. You can see it on the left side. Guardrail was there. It was hit. It is damaged and lying like that. And it itself poses a threat. There could be severe crashes later on this guardrail itself. On the right side, it's a photograph of a road which is not in a good condition. There's a sharp bend. Vision is restricted. We have no signing, no marking to guide the drivers. Next one, please. Yeah, we can move to the next. Yeah, other 2 pictures. One on the left side is a bad condition road. Drivers will try to avoid the potholes and waterlogged areas, and in the process can crash with other vehicles. And the right side picture is right on the side of the highway. There is a transformer. Vehicles, if they lose control, can go and hit the transformer and cause a major situation there. And this was constructed, and nobody took any action to remove the transformer to a better place. Next one, please. Yeah, so that was about road safety audits. I'll now go to the next section, which is International Road Assessment Program, IRAP. This is the international program, which is a road safety management tool. And this takes into account the Sustainable Development Goals of the United Nations and the Global Plan for Decade of Action for Road Safety. This is the tool that rates the crash potential. There are star ratings for road infrastructure, and it can be used for preparing safer road investment plans with urban countermeasures. Next one, please. The star rating is done based on various parameters. There are more than 50 attributes which are looked at while rating a road for its safety quality purpose. And this it is done by doing a safety inspection and by road safety impact assessments. 1-star road it has the highest risk, and 5-star road is the best, which is the lowest risk. And star ratings are produced without reference to detailed crash data. You do not have to have the detailed crash data analysis done to go into the rating system. VIDA is a software which is available online, free, and which is used to analyze the videos and data for rating and giving a safety score. Next one, please. So this is a star rating process. Starts with a road survey, normally by a survey vehicle with videos and photographs are taken, or else it could be from the design drawings. And these, all the roads are then coded in proper terms so that the software can be used. And then the data is processed and analyzed, and the star ratings are given. And safety ratings are safety numbers are also given for star ratings. And from there, investment plans can be prepared. And then designs can be modified. And again, the whole process can be repeated. The target is to optimize the star rating, improving it from 1 to 3 at least, and reduce the deaths and the serious injuries. Next one, please. These are screenshots from the VIDA software. As I said, 5, 4, 3, and 2-star ratings, and 1 is the lowest one, which is the highest risk. And we have the star rating scores. The maximum ones are for the 1-star facilities. And this figure on the left shows the network with various colors. The segments which have the highest rate, 1-star, are shown in black, and then red, and so on. Next, please. And the ratings are for various categories of users. The occupants of car, or the motorcyclists, or the pedestrians, or the bicyclists. The idea is to first assess what is the existing star rating and what percentage of roads are at that star rating. And then do initial design, see how it improves, do final design, how it improves. And the idea is to have at least three-star rating road systems. Next one, please. Okay, now I'll move into traffic engineering. Next, please. Traffic engineering, we all have an idea, basic idea of what traffic engineering is. It deals with the analysis of traffic movement on the road network, so that design facilities can be smoothly done for the smooth flow of traffic for safe and economic operations. And traffic flow is like the flow of water. Just like water flows through the pipes and the channels, traffic flows on the roads and various other facilities. And there are several parameters that are related to traffic engineering. Next one, please. Next one, please. The parameters are flow, density, speed, headway. Flow is by traffic volume, and headway is the separation between two vehicles, either in terms of time or in terms of space. Traffic volume is measured on the road. It is done by primary surveys by traffic engineers to collect the data from the road. It is a number of vehicles moving. There are various types of counts: classified volume counts, intersection turning movement counts, pedestrian counts, origin destination surveys. The purposes are different. When classified traffic volume counts, the number of vehicles are counted as per the class of vehicle, whether it's a car or a two-wheeler or what class of vehicle. Intersection turning movement counts are at the intersections where the turning movements are counted in terms of classes of vehicles also. Pedestrian counts are for counting the number of people who are walking along the road or across the road. And origin destination surveys are travel patterns. For the travel patterns, where normally it is done by roadside interview method, where vehicles are stopped and asked question of where you're going, where you're coming from, purpose, and so on. Next, please. Yeah. Next, please. Next. Yeah, this is just a typical vehicle classes. This is taken from IRC with motorized vehicles, non-motorized vehicles. And if it is done, if the volume count is done at the toll plaza, then what kind of toll exempted vehicles are there? It could be cars, trekkers, two-wheelers, four-wheelers, various types of vehicles. Next, please. Now we come to the concept of PCUs. We know that in urban roads there are various types of traffic that use the road. There's mixed flow of traffic, and putting them all in one unit is very important. So that is a passenger car unit, and various classes of vehicles can be converted to passenger car units. There are factors for that, and IRC 106 gives these. Next, please. In terms of PCU. Now, two-wheelers or motorcycles can be 0.5 or 0.75 depending on composition. What is the composition of two-wheelers in the total number of vehicles? If it's less, 5% or less, it's taken as 0.5. If it's more than 10%, it's taken as 0.75. And similarly for other modes of other classes of vehicles also. Next, please. The various types of volume counts are the average daily traffic, annual average daily traffic, average annual weekday traffic, weekend traffic, and so on. What we do is the traffic counts are collected for 7 days, or at some places 3 days. And the average daily traffic over the days are computed. And from there, seasonal variations are used to convert into the annual figures. And there's a process of using seasonal variations. Several data points are needed. Like, for example, if we have time series data at that location, we can understand what kind of seasonal variation can be possible. If not, then some surrogate figures are used, like sales of petrol or diesel throughout the year. And then we can from there find out what could be the seasonal factor and get the annual average daily traffic. Next one, please. This is an example of the variation in hourly flows over 24-hour period. And we can see clearly two peaks. Usually they're the morning and the afternoon peaks. Next one, please. This shows a typical composition of traffic. A pie chart showing typical composition of cars, non-motorized transport, buses, and so on. This can be in terms of number of vehicles, or it can be in terms of PCU also. Next, please. This is the typical table for ADT, where various types of vehicles are shown on the left side. And for various count stations, what are the numbers and what are the PCU values for those? And adding together, we get the ADT on which we apply seasonal factors to get the AADT. Next, please. Now, urban road classes, I'm mostly talking about the urban roads here. Either they're functionally different, or they're for design purposes, we look at different scenarios. For functional purpose, the roads are major arterials or minor arterials. Then comes the collector or distributor road, which feed into the minor and major arterials. Then the local roads, which feed into the collector and distributors. Then for design point of view, high-speed roads are designed in certain different ways. The access is less, mobility is high. And then as we go down, suburban, intermediate, and urban, access becomes more important and mobility goes down. Next, please. I'll talk here about the capacity and level of service. Capacity of a system is the maximum number of vehicles or passengers that can be carried in a given condition per unit time. The absolute number of people that can be carried, that's all. And the level of service relates to the quality of service of that flow. It's expressed in the US Highway Capacity Manual and also in the Indo Highway Capacity Manual in terms of letters A to F. A being the best, where it is free flow, and F being the worst, where it is nearly chock-a-block. It has practically reached the capacity. And next one, please. Here it's shown in a graphical form, operating speed versus V/C ratio. V over C ratio is the volume to capacity ratio, the volume of traffic on the road divided by the capacity. And as we see, as the volume of capacity increases towards 1, the operating speed goes down and the level of service also goes down from A to F. Next, please. There are different levels of service standards given by IRC. IRC 64 shows design service volume for various types of roads, for 2-lane or 4-lane or 6-lane road at the levels of service. Now, design service volume is the volume that facility can carry at that level of service. For level of service A, for 2-lane road, 10,350 vehicles per day is the maximum that it can carry at LOS A. So at LOS C, it's the capacity, it's the ultimate capacity. Next one, please. There's an important term for speed. There are spot speeds, running speeds, and journey speed. Spot speed is the instantaneous speed at a specific location. One can stand at a location with a speed gun and measure the speed of the vehicles going by. That would be the spot speed. Running speed is average speed over course. If we start from A and go to B, then divide the total length by the time taken to travel the distance, that is the running speed. Journey speed is slightly different. You're going from point A to point B, but you're also counting the stoppage time and the delay time, and you're dividing the distance by total time. That will give the journey speed. Next, please. And then there is the concept of 85 percentile speed, because we know that at free flow condition, when people can drive at whatever speed they want, they'll drive at a speed which is comfortable for them, is irrespective of the posted speed. And if you do the spot speed analysis and see at what speed most of the people, 85% of the people were driving at, and that gives us 85 percentile speed. Next one, please. Well, I'll go to the next topic, which is the traffic forecasting. Next, please. Forecasting. Next, please. Traffic forecasting is very important for designing of facilities for the future years. When we're designing roadways, we need to know what traffic it will carry, say 10 years or 15 years down the road. And the number of lanes have to be designed accordingly. Or widening is required in future year or not. Or additional toll plazas are required or not. It starts with the assessment of the base year traffic. And it is normally done by the primary service, which I talked about earlier, the average daily traffic, annual average daily traffic, and so on. And then, next please. And then we forecast the normal traffic. There are various types of data which are required. Historical data, traffic count data, if it is available at that location, then it is very useful because we can understand what has been the growth of traffic at that location. Or if it's not available, we look at other ways of doing it. Registered motor vehicles in that influence area is a very important piece of information to have because indirectly it shows the growth of traffic in the area. And other ways, finding out the relationship between traffic flow and the economic indicators, including population, per capita income, net state domestic product, district domestic products, and transport and these economic parameters are related. Next one, please, are related. And there's elasticity between the two can be estimated by doing regression analysis with various parameters, their values and the traffic values. And this growth rates can be estimated from there. And these growth rates are used to find out what would be the possible traffic in the future. Normally, three scenarios are done: an optimistic, pessimistic, and a realistic scenario to understand what kind of traffic can possibly occur in the future. Next, please. And in addition to the normal traffic and projecting the normal traffic for the future, there is a certain other aspects also. There is generated traffic, diverted traffic, induced traffic, development traffic. These are added to the normal traffic for the horizontal layer. Now, generated traffic is whenever you make a new facility or improve a facility, the traffic has a tendency to increase. Now, the quantification of this is the generated traffic. Diverted traffic is when traffic moves from other routes to this new facility. Induced traffic is when traffic moves from other modes or other times of travel to this facility at a different time. And these are all the various other aspects of traffic which will happen in future once a facility is improved. And with it is added the development traffic. Development traffic is a traffic from big development near the roadway. If there's a big mall coming up or some office complex is expected to come up, then what would be the increase in traffic? That would be the development traffic. And as I said, normal traffic is added to these to get the future traffic in the horizon years. I'll come to development traffic next. Yes, which is the traffic impact assessment. Traffic impact assessment is the study, is a tool to evaluate what are the potential impacts of the project that is getting developed on the existing and the future traffic of the network, and what kind of mitigation measures can be taken. Next one, please. If you look at the process of traffic impact assessment, first of all, it starts with description of the proposed development. What kind of development is being proposed? And excuse me, there was a train going. So establish the existing transportation conditions in the surrounding area and in the peri-urban area also at certain times. Determine the site generate traffic. What kind of traffic the site is going to generate in future? That has to be done. Calculate the future transportation conditions for the network and determine the transportation impacts based on certain threshold values, and then propose the mitigation measures. Next one, please. So first, the site plans have to be studied, and it has to be estimated what kind of traffic will be generated from this site. It could be a residential or office or commercial complexes. You have to estimate that type of traffic that will be generated. And then the modal speak part, but to understand what kind of modes will be used by these people who are going to access this facility. Are they going to come by buses or trains or cars or pedestrians or two-wheelers? And then the distribution is going to be on which accesses, the exit paths or access points. And then then do the assignment on the multimodal network in the immediate neighborhood and the wider neighborhood to understand the impact. Next one, please. And for this, the future network also has to be assessed from the plans, the developments that are expected to come up. There could be a plan for a new metro or a BRT services nearby, or there could be a elevated road proposed in the future. So this has to be taken into account. Then the operational analysis has to be done for the junctions, links, the overall network, and the threshold values have to be studied to see how these are going to react to the additional traffic. And based on that, the mitigation plans need to be developed and the cost estimates also, and the report has to be prepared. So this is overall the traffic impact assessment and overall traffic engineering, road safety, and transport planning in a very short period. Thank you.
Thank you for such an interesting session, sir. So let's move on to the Q&A session. So audience can raise any queries in the chat box, or they can raise their hand so that we can ask you to unmute. Any questions?
No question at the moment, I think. Only one person is asking for sharing the PPT. They're asking for his contact also.
Sir, they're asking to share the presentation.
Okay, I think I have shared it with you. You can share the presentation. Yeah.
Okay.
So there is a question coming in.
Yes.
Prabir, you can unmute. You can unmute and speak.
Okay, 1 minute. Am I audible, madam?
Yes, you are. Please go on.
Hello, sir. How are you?
Good morning. Yeah, good evening. Yes, I'm doing fine. How are you?
I'm still living, Praveer Datta. Now, I have one question. Of course, it is related to your subject, but it is roaming in my mind for many, many years because I live very near to Jasur Road, which is a national highway. Now, since you make the study, I understand whatever you have delivered right from 355, I have opened it and still now I am here. Now, how come this national highway, Jasur Road, it's a national highway. Part of it is state highway and rest is national. In between, some intermediate portion is declared as state highway and some part is still nomenclatured as national highway. Did you get the question?
Yes, I got your
It
question.
is partly national highway and in a intermediate portion it is a state highway.
Yes, I got your question. Actually, this naming of particular roadway, it is done on by various bodies. If a national highway has to be renamed, then alternative route has to be made into a national highway. Probably why it was done was because probably about certain section there's a bypass, and then that bypass is named as a national highway, and this is delegated to state highway. Or else it could be that a new facility is getting constructed, which will be a part of the national highway. And probably it's very difficult to widen. Knowing Joshua Road, it's very difficult to widen. Probably that is why a section of it is now a state highway, and the rest of it, probably they're thinking of a bypass or some other new facility which will be a national highway. Did I answer your question?
I think so. He has gone to give.
Yes.
Sir, there is a question in the chat box.
Yeah, okay. I have unmuted.
Okay. So, okay, then I'll moving to the next question, which is transverse bar marking is applicable to all black spots. That's first one. The second is under construction zones, there are more chances of road accident. Please explain. Okay. Transverse bar markings are those the thermoplastic bar markings which are placed on the road transverse to the direction of travel. Normally, they are 6 at a time, placed at certain intervals, depending on the speed on the facility. They are means of alerting the driver. When drivers are coming at a high speed, it goes over it is a noise and vibration, so alerts the driver to reduce the speed. Okay, now they could be used as a black spot. Again, black spot has to be studied. As I mentioned, that study has to be done on what type of accidents are happening, why they're happening, and then the remedial measures can be used. Possibly, yeah, transverse bar marking can be used, but again, that doesn't have to be used. There could be other solutions also, depending on what is exactly happening at that location. And the next question is, under construction zone, there are more chances of road accident. Yes, there are more chances of road accident, especially in our country. We do not do the construction zone management pretty well, though we have a very good code, but we do not follow it properly. And therefore, there is always a chance of accidents happening in the construction zone. And especially the vulnerable road users are susceptible. Pedestrians, cyclists, they have no way of going in the construction zone, and they're at high risk. And so I would say road safety audit during construction is very important to find out these points and take remedial actions. And there's another question. Please explain about transportation planning, which can be done at landslide locations or landslide locations. Okay, for the hilly terrain areas. Well, landslides are, okay, geological phenomena which happen, and then particular roads get blocked because of it, and unless it's getting reconstructed or maintained properly. There's a problem of landslides. And now, one way of handling it would be to find out alternative roads. And I think many of the hill states are doing it, having alternative roads, because if one is getting blocked, it can be used, or emergency measures can be taken up by using the alternative roads, because hilly areas will always be susceptible for this. Question is, which code is for construction management during construction? No, actually I said, just a minute, this went off. Where is it? Okay. During construction, work zone management. There's a code, I do not remember the number of it right now. Please search IRC code for work zone traffic management. There is a code which guides you on how to do it. I don't remember the number right now.
Someone has answered IRC SP is 54.
Okay, probably. I don't remember if it's SP 55 or not. I'm not very good at remembering the code numbers. How would decide between rumble strip and speed breaker before any intersection? What should be the case if intersections are within small distances? Okay, rumble strips or speed breakers. Now, first of all, in very high speed facilities, you should not be giving speed breakers because it can by itself cause a crash. Number one. Number two, rumble strips are better than speed breakers that way. You do not have to give rumble strips at every junction. Now, if there is been a long stretch without any junctions and it is seen that vehicles travel very fast in those stretches, then in order to bring down the speed, you can use the rumble strips. Okay. And on major arterial roads, or definitely not on the national highways, you should not be giving speed breakers. You can give speed breakers on the lesser roads which come and meet the highway so that they can stop there and then meet the highway, but not on the major highway. Then traffic calming measures. Yeah, traffic calming measures have not gone into it. As it is, I have covered so much of stuff in 1 hour. Yes, you can have traffic and calming measures, especially in the residential areas, to calm down the speed, so that there are various ways of doing it. Again, there's an IRC code which talks exclusively about the traffic calming measures. There could be, chicanes. There could be visually aesthetic measures that can be taken so that speed is brought down. Then can you provide rumble strip under construction area on NH roads? Under construction areas on NH road, yes, you can, because it's a construction zone. You can, provided it is required, you can. But if you can do without it, it'll be better. But there are other methods of diversions, and if diversions can be given in a proper manner as per the code, they are quite effective. As I said, most of the times we do not do it as per code. What kind of measures can be initiated on sharp curves with chances of skidding? Okay, sharp curves. First of all, it's a geometric design issue. How sharp a curve can you put under what conditions? And then when you are doing an audit, you can always check whether that curve is suitable for that speed and for that surrounding. And if there is no way of widening it, giving extra widening or giving flatter curve because of certain restrictions of land use or right of way, then at least make sure that proper signing, marking are done so that people are warned. Guardrails are put up so that people do not skid and fall off, and preferable to have lighting. Box marking at important intersections. Box marking it means that that intersection should not be occupied. You enter the intersection only if you can clear it, right? But unfortunately, that is not obeyed by most of the drivers. First of all, even if you put box marking, most people do not know what that is and do not follow it. I'm talking of the negative side. But yeah, whether it should be given or not, I do not think you should give box marking for all intersections, only at the major intersections where you do not want the vehicles to stop in the middle of the intersection and waiting for the next signal and blocking the other direction traffic. But again, as I said before, it is difficult to enforce. what will be the maximum gradient that can be provided in a hill on hill roads? Well, this again, I do not have it memorized. I cannot tell you what percentage of gradient should be used in hill roads. These are given in the IRC code for hill roads. For various types of facilities, what could be the maximum gradient and what class of road, if it's a national road, highway or a state highway or a local road or a district road, what is allowable maximum gradient? Those are given in the code. Please refer to the IRC code. It is given. So you asked for NH, yeah. This is given in an IRC code, which is what should be the ruling gradient, what should be the maximum gradient, and what could be the allowable gradient, and so on.
I hope most of the questions are over. So thank you for answering that also. It's very clear from the number of questions that it is how interesting your session was. So I am handing over back to Asim.
Thank you. Thank you for all the questions also. And some of them are quite interesting questions. As I said, I just gave a very hurried overview of the entire subject, which would probably have taken 3 sessions to cover. Okay, and thank you for listening.
Thank you, Suvendu sir, and thank you, Ranjita, for your words. And now I ask Narayana sir for his closing remarks.
Mr. Suvendu, I think I must really thank you the great amount of effort that you have put in to actually bring in the vast ocean of knowledge and practices into a short session. I can imagine how much amount of hard work it would have been taken to you to really compress this and bring this in a very beautiful form so that, you know, even a non-planner or a practicing engineer understands the fundamentals. So from the entire team of CEI, the Youth Forum, the Secretariat, and the entire participant fraternity, many thanks for all the efforts that you have done, and you have spared your valuable time to talk to us and give us this sort of in-depth knowledge. We really express our sincere thanks for your effort. Not less than that, I am very thankful to the Youth Forum led by Asim, Ranjita, Meher, and the team at CEI. Their enthusiasm in terms of bringing new topics to the fellow engineers and members, non-members, in terms of, you know, their enthusiasm really is highly appreciated. So we keep on moving this with the inspiration, and we will have soon more interesting webinars to come up. I also would like to thank the entire participants who have taken the time today to be part of it us, to be having patiently listening, and also bringing in some very interesting questions. I'm sure there will be lots of thought processes after this presentation and discussion. We welcome all that, and then we also appreciate your time. Thank you very much. Also, the staff at Secretariat who have been constantly working hard to really make this webinar happen. So big thanks to the entire team at the Secretariat and the team out there elsewhere and in the other CEI regional centers to really work hard and get done. So I take this opportunity to thank each one of you for this fantastic session, and especially Suvenduji for a fabulous, it was really encouraging. I can really understand the amount, being a transport planner, how difficult it is to really make it happen in a short time. Thank you very much. Thank you one and all. That's it from our side. Thank you.
Thank you, sir.